All right, so welcome back to everyone. A warm welcome to all of you, the NEET aspirants, and we are preparing for NEET 2024. And today I am going to tell you about the error analysis. Okay, so guys, this is the series in which we are completing our units and measurement. We are completing our units and measurement chapter, units and measurement chapter, and in this session, we are going to continue from where we have left in the last session. Okay. So in the last session, we have completely understood about the significant figures, right? We have completely understood that how we can round off the significant figures, how we can do multiplication, division, addition, subtraction of the significant figure, and also we have learned that what is the significance of the significant figure and why it is important in this world of physics. Okay. Okay. So guys, in this session, what we got to do? So in this session, we are going to talk about the errors. Okay. Okay, and we'll be talking about the error analysis. So guys, I am Dr. Shankar Sir, your physics educator, and I welcome you all again on your own channel, NEET Success Simplified. Okay, so let's come to the point without wasting your time. So we have this error. So in this session, we'll be talking about the errors. Okay, and we are going to analyze. We are going to analyze these errors. Okay, we are going to have an analysis of these errors. Okay. Okay. Now, what is the error? Okay. Now, in this world, please try to understand this. In this world of physics, see, whenever you are measuring some physical quantity, okay, so each and every quantity has to be measured at some point. Okay. Okay. Like, for example, length, width, height, volume, area, density, weight, mass, force, okay, pressure, strain, stress, temperature, resistance, current, voltage. Okay, so all these things at some point are going to be measured and they need to be measured for understanding the physical phenomena. Okay, okay. Now the problem is, what is the problem? What is the problem? So problem is that no matter how hard you try, no matter how hard you are trying, there will always be some error in your measurement. No matter what accuracy of equipment you are using, there will always be scope of some error in your measurement. Okay. Okay. So what we can say, so no matter how hard we try, no matter how hard we try, there is there is always some error. There is always some error in measurement. Okay, in measurement. Okay. Now due to this, there is due to this, there is always a difference, always a difference, always a difference between between the measured value between the measured value and true value between the measured value and true value. Okay. Okay, so no matter how hard we try, the true value, the absolute value, the actual value, you can never reach to that. Okay, it is extremely hard, nearly impossible to get the true value. True value is what is the actual value of something. So no matter how hard we try, there is always some error in measurement, and due to this, error comes up. Due to this is giving the birth of the error. So no matter how hard you try to measure some physical quantity, there will always be some error of that measurement from the true value. Always be some difference from of that measurement from the true value. So this gives the birth to this basically gives the birth to the world of this error. Okay, okay. Now please understand this. Now please understand this. So we have the absolute error. Let's define what is absolute error. So absolute error, it is basically the difference, the magnitude, we can say the magnitude of the difference. Now please try to observe the magnitude of the of difference between, I should write it here, between true value and measured value. True value and measured value. Measured value. So the magnitude of the difference between the true value and measured value is called as the absolute error. Is what we call as the absolute error. Okay. Okay. So what is absolute error? So there is some true value. There is some there is some measured value. The difference between the true value and the measured value, when you see the magnitude of it only, when you observe the magnitude of it only, you are going to have the absolute error. Okay. Now the problem is that you only said that however hard we try, we are not being able to get the true value. There is always some difference. There is always some difference between the measured value and true value. Okay, so the measured value we can get, but from where the true value will come from? The question is from where we are going to get the true value, because we have just understood this fact that no matter how hard we try, we can never get the true value of something. We can never get the true value of something. Now, what do you think we can do to get that true value? We don't know the true value. Nobody is telling us the true value. Okay. Sir, but we must know the true value. Or if we would have known the true value, why would we taking the pain of measuring? When we are measuring something, that means we don't know its value. Otherwise, what is the meaning of measurement? We won't be measuring it. Do you agree to it or not? When we are measuring something, when we are measuring something, when we are measuring something, so it means that, when we are measuring something, it means that we don't know its true value. And no matter how hard we try, we can never get the true value. Now the question is, if we can't get the true value, from where we are going to get the absolute error? And unless we get the absolute error, how we are going to proceed in this chapter? Okay. Okay. Now please understand. Now please understand this. Now what we can do? What is your suggestion? That how we can come up with a true value of something? What we can do to get the true value of something? So what we can do to get the true value of something? Sir, what we can do? We can take multiple measurement of something. Take multiple measurements of something. See, this is the best way to get the true value. Even this value is not the true value, but in physics, we must take some true value. Now, obviously, it will be more closer to the true value. This is what I can say. So, what we can say, what we can do, we take multiple measurement of some physical quantity. PQ is what? PQ is the physical quantity. So we take multiple measurement of some physical quantity. Then so let's suppose we have x1, we have x2, we have x3, we have x4, and similarly we are having this xn. Similarly we are having this xn. Okay. Okay, so this is the true value, this is going to be, so this is the measured value. So you have taken the multiple measurement. So when you take multiple measurement, let's suppose we are having a length, and for that length, just to get the true value of that particular length, what we are trying to do, we are trying to take multiple measurement. Okay. Now, when we take the multiple measurement, let's suppose we are getting x1, x2, x3, x4, x5, x6, x7 to xn. So what we can do, what we can say, the true value, remember this, true value or the actual value, the true value or the actual value, for this, we can take average of all these measurements. So what is going to be the average of all these measurements? So it is going to be x1 plus x2 plus x3 plus x4 plus xn. divided by n, divided by n. So this is going to be the true value. This is going to be the true value. Okay. Okay, so what we can do, we can take multiple measurements of some quantity. Then what we can do, we can take the average of that measurements, and then we can say this is your true value or actual value. Because obviously, if you think, you can think that this value is going to be the nearest value we can ever come to the true value of something. Right? The true value only God can tell. Okay, but as a human being, we can try to approach the value of that, and how the best way to approach to it, to take the multiple measurements, take the average of it, and by doing so we are closest to the true value. So for the physics, for in the world of physics, we consider it we consider it the we consider it the true value for our purpose of the measurement. So it is sometimes told as the mean value, anything. So when you see the question, you will get to, you will get to understand, you will get to see, you get to know that this is your true value. Okay. By the, by the language of the question itself, it is, hinted towards you. Okay. Now we have the true value. Okay. So we have taken the multiple measurement, we have the true value. Now what we want to do is, we want to calculate the mean absolute error. We want to calculate the mean absolute error. Okay. Okay. Because see, why we want, so see, when you are giving the true value of something, you want to give the error, because in this true value, is this true value error free? Is this true value error free? No, sir, this is also not error free. Na? Is this error free? This is close to the actual value or the real value, let's say, given by the God, but it also has some error. Okay, is it error free? No, sir, it also has some error. Okay. Now, when we have this true value, we also must know that what is the error in this true value. What is likely to be the error in this true value? So for that, we need the mean absolute error. So how we can get the mean absolute error? So let's suppose in the measurement 1, there must be some error. Let's call it delta x1. So what is the error? What is the true value? True value. So we can call it x or x2, xm, whatever you want, whatever you feel right. X, or you can write it as xm, whatever you want. Whatever you want, you can write it. Okay, so I am using x. Okay. So what is the error in the first measurement? So it is x minus x1. What is going to be the error in the second measurement? It is x minus x2. What is going to be the error in the third measurement? It is x minus x3. And so on. So on. What is going to be the error in the nth measurement? Okay, in the nth measurement. So why we think you do this n thing? Because see, you can put any number in the term of n. No? So this is, oh, I have written x3 here. Sorry. This is x minus x3. And now what is going to be the delta xn? So delta xn is going to be x minus xn. Now, this way you are getting absolute error in each of the measurement. Okay, each of the measurement. And remember, we just have to take the magnitude of that. Okay, so you can either write the mod of it. So what is going to be the mean absolute error? MAE what? It is the mean absolute error, and it is normally denoted as delta x mod. Okay. Okay, because we are interested in the magnitude only. So we have this as delta x. So what it is going to be? So it is the mean of the absolute error. So what we are going to do? We are going to write delta x1 plus delta x2 plus delta x3. Okay, plus delta xn. Okay, divided by n. So delta x1 plus delta x2 plus delta x3 plus delta xn divided by n. So mean absolute error is going to be this value. So you are going to get some value here, and remember to take mod. Okay, mod. That means that you are only taking the magnitude. Okay, only taking the magnitude here. Now please understand this. So what we are trying to do, we trying to measure some physical quantity. Let's suppose it is the length. Okay, and you want to be as near as the value given by the God. Okay. Okay, so for that, what you have done, you firstly have calculated the true value, okay, by taking the multiple measurements, and obviously more measurements you do, more near you will be the true value, more will be your accuracy, right? Now delta x is the mean absolute error, okay, mean absolute error. That is, what is the error this what is the error this mean value or the true value is carrying. Okay, so mean absolute error is delta x. Now please understand this: any physical quantity, any physical quantity, any physical quantity shall be represented as, shall be given as, any physical quantity shall be given as x plus minus delta x. Now remember this, okay? Okay, so when we are measuring something, it should be actually practically it should be the length or the measurement should be given like this: x plus delta x. Now what does that mean? So it means that the estimated true value of this physical quantity is x. The estimated true value of this physical quantity is x. Okay, while the mean absolute error, that is the likely error, the most likely error in this true value is going to be delta x. So any physical quantity shall be given as x plus delta x. It shall be given as x plus minus delta x. So this error can be on the positive side. That means it can be added, or this can be subtracted. This can be subtracted. Now there are a few more terms. I hope this is fine. How to calculate that true value, how to calculate the mean absolute error. Okay. Okay. And now we are going to see some more definitions. So there is something known as relative error, okay, or fractional error, relative error or fractional error. Okay, so what is this relative error or fractional error? So what can we say? So this relative error or fractional error, we can call it as delta x by x. Okay, okay, that is mean absolute error, mean absolute error upon the true value, upon the true value. Okay, so the relative error is the mean absolute error upon the true value. Now we have something known as the percentage error. What is this percentage error? What is this percentage error? So this percentage error is going to be equal to fractional error into handwritten. So we are taking the percentage of this fractional error into handwritten. So we can write it as delta x by x, delta x by x into handwritten. So this is going to be the percentage error in any measurement. Now guys, let's do one question. Let us do one question. Okay, let us do one question. So let's suppose the different measurements. Okay, and I'm giving you a little bit lengthy question so that you can apply all the formulas you just have seen. See, when you apply the formulas, when you apply the concept we see, you will be more and more, more and more comfortable in that particular formula, in that particular topic. Because in examination, you don't have this much time, to explore. So the thing is, more practice you do, more better you will feel. Okay. So what is given to us? So the different measurements of length, the different measurements of length, the different measurements of length of a rod are 4.2, 4.5, 4.4, 4.3, and let's suppose 4.6 in a centimeter. In centimeter. So we need to calculate the following. We need to calculate the mean value. Okay. You need to calculate the mean value. Secondly, you need to calculate the absolute error. absolute error. Okay, absolute error. Then you need to calculate the mean absolute error. Mean absolute error. Okay. Then you need to calculate the fractional error, and then you need to calculate the percentage error. So nearly everything what we have learned till now, you need to apply those concepts. You need to apply those concepts in this. Please go for it. Please go for it. I'm very sure we can do it. Please try to do. Please try to do. I'm quite sure we can do this. Very, very easy. Nothing to worry about. Nothing to worry about. Very, very simple. So guys, before I always suggest you guys, I always request you guys for this, that you must always solve the questions before we do it in the session. Okay. If you are watching the recorded version, then please pause this video. Please do pause the video, and after pausing the video, you attempt the problem. Okay, before I do. So what it says the different measurement of length of a rod are 4.2, 4.5, 4.4, 4.3 and 4.6 in centimeter. Calculate the mean value. So see, what someone has done, as I was trying to make you understand, that length of a rod is 4.2, 4.5, 4.4, 4.3 and 4.6 in centimeter. Okay. Okay. Now see, now please understand this. Now one has tried to measure the length of something, the length of the rod, and in order to approach to the true value of the length of the rod, he or she must have taken multiple measurements. Now when she have taken or he have taken multiple measurements, he or she again. Okay. Okay. So he or she again might be getting these values 4.2, 4.5, 4.4, 4.3 and 4.6. Okay. Now in this case, we are supposed to calculate the mean value, the absolute error, the mean absolute error, the mean absolute error, fractional error, and percentage error. Now please understand this. Now please understand this. What is going to be the mean value? What is going to be the mean value? Okay. What is going to be the mean value? So we, for mean value, we must take the average. Okay. We must take the average. So mean value, that is x. So we have 4.2 plus 4.5 plus 4.4 plus 4.3 plus 4.6 divided by how many measurements were made. So the 5 measurements were made. Now if I calculate it, let me calculate it with using calculator. Okay, so you don't do that, right? You don't do that. So we have 4.2 plus 4.5 plus, oh sir, you are using the calculator. Oh, because I'm the teacher, no? So I can take this liberty. You don't use the calculator. You must be fast in your calculations. Okay, so this is divided by 5. Okay, so what are we getting? We are getting 4.4 exact. Okay, we are getting 4.4. So what is the mean value? The mean value is 4.4. Okay, mean value is 4.4. Now please remember. Now please remember this concept. Okay, so remember the chapter of significant figure. Now if it would have been come out to be 2 digits after decimal, you must have to then reduce or round off that to one significant figure. So basically the concept of significant figures that we have used. So we have added the significant figures, we have subtracted the significant figures, we have multiplied, divided them. Okay, so whenever you are dealing with the errors, you will always have to use the concepts of the significant figure. Okay, you need always to use the concept of the significant figure. So here we are adding some significant figures. So when we are adding the significant figure, the final solution must be rounded to the same number of decimal places as present in the value with the minimum decimal places. Okay, so here it is 4.4, so no problem. Now mean value is sorted. Okay, mean value is sorted. This is 4.4. Very good. Now absolute error. Okay, absolute error. So this is the first part of the question. The second part of the question says so we need to have the absolute error. So how we can get the absolute error? So in each of the measurement there will be some error. So delta x1 is going to be x minus x1. So we have x and x1 is 4.2. So putting the value of x and x1 we are getting 0.2. Now delta x2. So delta x2 is going to be x minus x2. So it is going to be 4.4 minus 4.5. So it will be minus 0.1. Then we have delta x3. So this delta x3 is going to be x minus x3. So that means 4.4 minus 4.4. This is 0. Okay, sir, it is coming out to be 0. I mean, you don't worry about it. You just do the calculation. Okay, in this particular measurement there is no error. Okay, okay, but still is that error free? Is that measurement error free? No, but because you have to see the cumulatively, right? You have to see it cumulatively, right? Now please understand this. So we have this x minus x3. Then we have delta x4, that is x minus x4 is equal to how much? So x is 4.4, this is 0.3. So again we are having 0.1. And then we have delta x5. Then we have delta x5 and it is going to be 4.4, 4.4, 4.4 and 4.4 minus 4.6 minus 4.6. So we are getting minus. So I'll not write it. I'll write x minus x5. So we are getting minus 0.2. Minus 0.2. Now please remember this. So the third part. So see, this is the absolute error you have found for each of the measurement. For each of the measurement, this is your absolute error. Now after finding this absolute error for each of the measurement, you need to find the mean absolute error. Mean absolute error. So what is the mean absolute error, guys? Sir, it is the average of all the absolute errors. Now many may get this wrong or may make a silly mistake here that they think that the mean absolute error is going to be 0. Okay, they may think so. Okay, why they may think so? So they may think so because the 0.2 minus 0.1 here, 0.1 minus 0.2, so it is getting 0. No, remember this thing that in mean absolute error, whenever we are calculating, we must take the mod of each of the absolute errors. That means that we must be only using the magnitude. Okay. Now when I'll be using the magnitudes only, so we are having it as see 0.2 plus 0.1 plus 0 plus 0.1 plus 0.2 and this is going to be divided by what? So how many measurements were there? So 5 measurements were there. So what we are getting from here? So when we calculate it, so it is getting so 0.1, 0.1. So it is going to get 0.6. So 0.6 divided by 5. 0.6 divided by 5. So I guess we are getting 0.12, right? 0.12. Okay. So what is the mean absolute error? The mean absolute error is 0.12. Is it the right answer? No, this is not the right answer, guys. This is wrong answer. Why it is wrong? Because in the errors, when you are dealing in the errors, okay, when you are talking about the errors, you need to use the concepts that we have learned in the significant figures. Okay, what was the significance? Why significant figures are used in the first place? The significant figures are used in context to the measurements. Errors also are used in context to the measurement. So whatever concept we have learned in the significant figures, we have to apply it in the errors also. also. So now this is wrong. So what is going to be the right answer? It is going to be 0.1. Why so? Why it must be 0.1? So it must be 0.1 guys because it must be 0.1 guys because whenever significant figures are added, the final answer must be reduced to must be rounded off to the same number of decimal places as present in the value with least decimal. Okay, so we have the mean absolute error here. Now, after the mean absolute error, we are supposed to find the fractional error. Okay, we are supposed to find the fractional error. So, what is going to be the fractional error? Fractional error is delta x by x. So, delta x is the mean absolute error. So, that is 0.1, and this is going to be 4.4. This is going to be 4.4. So, whatever we are going to get from. Okay, I leave it to you. Okay, I leave it to you. Now, the percentage of this fractional error. So, what is the percentage error? What is the percentage error? So, this percentage error is going to be delta x by x into 100. Okay, so you have delta x by x, that is obviously 1 by 44 into 100. So, from here, guys, you can get the percentage error as well. Okay, I hope it is fine to everyone. Yeah, is it okay? Is it fine to everyone? Please answer me. Yeah. So the live students can always respond, and the students who are watching it live recorded version, they can tell me in the comment. Okay. So guys, dealing with this error thing, what is mean absolute error, what is what is the fractional error, what is the percentage error, what is the true value, what is the actual value, mean value. So they are all the same thing: true value, actual value, mean value. So in the world of units and measurement, that is the same thing, but other thing, right? I hope it is fine to everyone. Now let's talk about the propagation of errors. What? The propagation of errors. So what do we mean by the propagation of errors, and what we intend to understand here? So guys, please understand this. Please understand this propagation of errors. So basically when we talk about the propagation of errors, so see when we are, like, see, we have seen in the dimensional line, so there are so many formulas. Okay, now let's suppose we have a formula of some physical quantity. So here what we are trying to do, so we are having some formula of some physical quantity. So for example, F is equal to ma. F is equal to mass into acceleration. Now, please understand this, guys. Please understand this. Now, when we say F is equal to ma, so if you want the force, okay, you can measure the mass and you can measure the acceleration, right? Now, please understand this. There will be some error in this measurement, some error. We don't know what would be that error, but there will be definitely some error. Okay, and there will be some error in this acceleration. Okay, some error in the acceleration. Now, using the value of mass and acceleration, you have calculated, using the value of this mass and acceleration, you have calculated this thing, you have calculated this thing, that is force. So obviously there will be some error. Obviously there will be some error in the force also. There will be some error in this force also. Okay, in the measurement of this force also, because there is some error in the mass, there is some error in the acceleration. Now you are combining these two things to get another thing. Now that another thing must also have some sort of error in that, right? Obviously. Okay, now in the propagation of errors, what we are trying to do here, we are trying to see that when two physical quantities are added, when two or more physical quantities are added or subtracted or multiplied or divided, whatever happens to some physical quantities, and as we know, each of that quantity will possess some sort of error in their measurement. So what is going to be the cumulative error or the final error in the final thing that you want to calculate? Okay. Okay, so propagation of errors in the sense that when you add, subtract, multiply, divide the physical quantities having the errors, whether what is going to be the error of the final physical quantity that you intend to find. Final physical quantity that you intend to find. Right? I hope it is fine to everyone. What is the meaning of propagation of error? Now, what are the things? So we have addition, subtraction, we have multiplication and division. So first of all, let's talk about the addition and subtraction. Let's talk about the addition and subtraction. Okay. Addition and subtraction. So when we do this addition and subtraction, when we do this the addition, when we do the addition and subtraction, so basically what happens? Now please remember this. I'll give you the statement, then we are going to see. So errors are always added. Now please remember the error are always added. Okay, added in addition and subtraction. Okay, so whether, now remember, whether it is addition, whether it is subtraction, whether it is addition, whether it is subtraction, you need to add the errors. Please understand this. In addition also, you will add the error. In subtraction also, you are going to add the error. You are not going to subtract the error. Errors are always added in addition and subtraction. Remember this statement. I can prove this in 100 ways. I can take 100 examples and I can prove it to you. So let's take a few examples and let's try to figure it out. So let's say we have two quantities. Okay, let's try to understand with the help of example. So let's suppose we have 3 plus minus zero point 0.2 and we have another quantity, let's suppose 2 plus minus, so we'll call it zero point 0.3 and we'll call it zero point 0.2. No worries. So we have, let's suppose 3 plus minus zero point 0.3 and we have 2 plus minus zero point 0.2. 2 plus minus zero point 0.2. So now we need to add them. So what we can do? What we can do simply, very, very simple. We can understand it in one go. So sir, in addition, errors are always added. In addition, errors are always added. And see, this is the true value or the mean value. This is the true value or the mean value. So right away you add simply as you do. Simply add the true values. Okay, so you have added the true values. Now you need to add the errors. You need to add the errors. Okay, 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 okay. Now please understand it. Let's try to take the feel out of it. Now please understand. What do you understand when I write 3 plus minus zero point 0.3? So that means that when someone has measured it, when someone has took this measurement, when someone has took this measurement, he may get the measured value. Okay, he may get the measured value anywhere between 2.7 to 3.3. Okay, when I write with a quantity that the quantity is 3 plus minus zero point 0.3, so that means that in a measurement it can be 2.7, it can be 3.3, it can be 3.3. So you must have seen. Now I'll give you one example. See why this thing comes up, because later on practically where it is getting used. So see, you must have seen small products available in the market. Like for example, we have nut bolts. Okay, nut bolts. Now nut bolts, what do you think? Every nut bolt, when they are manufactured, are someone is going to measure each and every nut bolt through a vernier caliper or screw gauge, then dispatch it to you? that bold cost will become 100 times when it reaches to you. Are you getting my point? Okay. Okay. So what is done? So they have standardized their manufacturing system somewhat. They are using the automatic machine, artificial intelligence, so many things are there these days. So they are using the automated machine, they are using the assembly line, and they are making these sort of a product in a lot. Now, let's suppose in a box full of these nut bolts. So when we have the box full of these nut bolts, so if you say what is the length of these bolts, on the packet it will be written like 3 plus minus zero point 0.3. So that means you pick any bolt out of that box, its length would be anywhere between 2.7 to 3.3. 2.7 to 3.3. Please understand. It is going to be 2.7 to 3.3. Right? Okay. Okay. Now see, whenever in measurements, we are always interested in what, sir? We are interested in the maximum error. That what could be the maximum error in some measurement. Okay. Now, either side, on the negative side or on the positive side, the maximum error could be, so the maximum error could be on the positive side, it could be 3.3. On the negative side, it could be 2.7. There can't be more error than this. Okay, there can't be more error than this. So when we are adding these two quantities, now please understand, now for example, for this next quantity, for this other quantity, what could be the maximum errors? So it may be from 1.8. So one could measure 1.8, or one could measure 2.2. Okay. So the value of this lies in between. I write it as measured value. So the value of it lies in between 1.8 and 2.2. Now, when will be the maximum error? When will be the maximum error? So when will be the maximum error, guys? When will be the maximum error? So the maximum error is going to happen. Maximum error is going to happen. When these two quantities are added. So when is going to be the maximum error? The maximum error is going to be when the maximum error values of each of these values are added. Okay. So maximum value will happen if this is added to this, and maximum error will happen when this is added to this. Right? This is added to this. Do you agree or not? This is when the maximum error is going to happen. Right? Now these two added, you are going to get say 4.5, and when these two added, you are going to get 5.5. So you are getting the same thing now here. That what is the maximum range of it? What is the maximum error you can get on the positive side? What is the most errored value on the positive side? It would be 5.5. And what will be the most error value on the negative side? So it will be 4.5. Now, when I write 5 plus minus zero point 0.5, it means that again, that the measurement of this ranges from 4.5 to 5.5. So each way you are getting the same thing. So just to say it, errors are always added. Now please remember, see, in the examination you don't have this much time, guys. Okay, do you have this much time? We have 3 hours 20 minutes and we have to do 180 questions. So nearly 66-67 seconds we get to each question. Are you going to think this much in the NEET examination? No, sir. Okay, no, sir. It is absolutely impossible. Okay, and it is not advisable even. You just use this thing. What you must use? Errors are always added in addition and subtraction both. Okay, in addition and subtraction both. So let's suppose that we are going to have, let's suppose we have this, we have this. So now we have this and we have this, same question. Now we need to subtract it. Now we need to subtract it. We need to subtract it. So when we are subtracting it, how we can subtract? So first you subtract the true value. First you must subtract the true value. So it is going to be 1. 3 minus 2, that is 1. So you subtract the true value or the mean value as you do in general. So 3 minus 2 is 1. And now 0.3 plus 0.2, it is going to be equal to 0.5. Don't subtract the errors in the subtraction, because errors are always added, whether it is addition or whether it is subtraction. Whether it is addition, whether it is subtraction, errors are always and always added. Okay, okay. So 3 plus minus 0.3 and 2 plus minus 0.2, you are going to get 1 plus minus 0.5. And you can think in this way. See, these are the extremes. So 2.7, 1.8, 3.3, 2.2, 3.3, 2.2. Okay, okay. So what you can do? So when you get the maximum error, when you get the maximum error, okay. So when you are getting the maximum error, when you are getting the maximum error, when you are getting the maximum value, when you subtract them. So for that, you need to subtract 3.3, 1.8. Now think in this way. You are subtracting two quantities. When will be the maximum error? The maximum error will come when one quantity is at its least value and the other quantity is at its maximum value. Then only the error will be maximum, na? Because you are subtracting. When you are subtracting, when will be the maximum error? When the maximum value of something is subtracted by the least value of something. Okay, okay, right. So when you subtract 1.8 from 3.3, what you are going to get? What you are going to get? You are going to get 1.5, right? Now similarly, least value of this quantity to the highest value of the other quantity. When you are subtracting two quantities, the maximum difference you are going to get when you are subtracting the most extreme values, when you are subtracting the most extreme values. So either way, you are going to get this. When you subtract 2.2 from 2.7, you are going to get zero point 0.5. And when you subtract 3.3 to 1.8, you are going to get 1.5. Oh, sir, can we do this much in the examination? Arey, you hardly have, I'm guessing you have 66 seconds for each question. You have 66 seconds to each question. You don't have to think this much. You just apply the concept. Sir, whether it is addition, whether it is subtraction, errors are always added. Okay, okay. Now there can be n number of questions that we can do here, but I'll keep it to just one or two questions, because I think this is a very simple concept. So let's suppose we have two resistances connected in series. So let's suppose this is R1, this is R2, and we have some value of R1, that is 2 plus minus zero point 0.2 ohm, and we have some resistance of R2, that is 4 plus minus zero point 0.4. Okay. Now you need to give me the final resistance. You need to give me the final resistance. What you got to give me here? You got to give me the final resistance, okay, of this circuit. So final resistance of this circuit. So what is going to be the final resistance? So we know when two resistances are connected in series, so they are added. Two resistance connected are in series, so their equivalent is added. Or is that till now we haven't done the current electricity? Okay, okay. Arey, what is the need of that? We have done this in 7th, 8th class, no? Okay. Okay, so R equivalent is R1 plus R2. So this is going to be how much? See, you add the true value and then you add the errors. Very simple, isn't it? Very simple. What can be more simpler to this? Okay. Whether it is addition, whether it is subtraction, errors are always added. So let's suppose we have the temperature 100 plus minus 2 Kelvin, and we have this temperature T2, that is 50 plus minus 5 Kelvin. Okay, 50 plus minus 5 Kelvin. And now you need to get T1 minus T2. So you need to give the temperature difference here. You need to give the temperature difference here. So what is going to be the temperature difference here? What is going to be the temperature difference here? So the temperature difference is going to be, so first we will subtract the true value. So we're getting 50, and errors are always added. Errors are always added in addition or subtraction, whatever it is. Okay. Addition and subtraction errors are always added. Okay. Errors are always added. Right? Okay. I hope it is fine to everyone. So, sir, now we have understood the propagation of errors in both addition and subtraction. Again, repeating myself so that it goes in your mind more beautifully, okay, more perfectly. So, whether it is addition, whether it is subtraction, whether it is addition, whether it is subtraction, the errors are always added. The errors are always added. I hope this is clear to everyone. Now let's move to the next part, multiplication and division. Let's move to the next part. We are going to move to the multiplication and division. So we are done with what? We are done with the addition and subtraction. Now we are going to do with the multiplication and division. So we are going to see that how the errors are going to behave, how the errors are going to propagate in the case of multiplication and division. In the case of multiplication and division. So see how we are going to do that. So let's suppose we have x is equal to AB. Okay, x is equal to AB. Now what is going to happen? So A must have some error. Okay, let's suppose A is having some error of delta A, B is having some error of delta B. Okay, okay. So now how you are going to write this x? So sir, very simply, x is equal to delta A, delta x is equal to delta A plus delta B. Okay, okay. So guys, this is not the way crossing. This is not going to work for you. This is not that way. Okay, that is not the right thing to do. Okay, this is wrong. Now what we have to do? So we have to apply the principle of differentiation. Oh, so differentiation. Don't worry. I'm just flatly giving you the formula. The formula is very, very simple. You can memorize it quickly. No worries. No worries. Sir, do we need to do some differentiation in studying the physics bonding? Some differentiation is required. I will be telling you just to the point how much differentiation you need. I won't teach you even a single thing more than what you need. Don't worry. Okay. Now, from the principle of differentiation, we can write, see, delta x upon x. See, when I write it once, you will be able to understand. Delta a by a plus delta b by b. That's all. That's all. Very, very simple, no? Delta x by x is equal to delta a by a plus delta b by b. Very, very simple. So just when you are dealing with the errors, you have to deal it like this. Okay. So sir, from where we'll get the delta x? So from here you can get the delta x. No? Delta x is equal to delta a upon a plus delta b upon b into x. So we have the value of x. If we have the value of x, if we have the value of a, delta b, b, etc. So we can get the delta x, and we can obviously then say x plus minus delta x is your value of this multiplication. Now this is multiplication, so what happens if we divide? What happens if we divide? So obviously your mind must be saying this, that sir has written both together, so definitely they must enjoy to have the same rule. So see, you don't have to do anything. So if x is a upon b, x is a upon b, you can write, see, same delta x by x. This is the principle of differentiation. You can see it. Okay, okay. But you don't need it because it is too simple, na? Why you must know the reason for it? As I say, see, in the examination, it is very, very important that you manage your time as well. Okay, your time is your, what we say, your time is money there. Your time is simply money out there, right? Are you getting my point? Why it is money, sir? Why it is money, sir? It is money because if you waste your time there, you are not going to get a good rank in the NEET. If you are not going to get a good rank in the NEET, how you will become the doctor? If you don't become the doctor, from where, you see, right? Simple logic, simple math, right? Now let's do some problems. Let's suppose we have a rectangle, and this rectangle has some length and some width. Okay, now please think. Please think. Now please always try to think physics practically. Physics is a very, very practical subject. Physics is a very, very practical subject. Okay, okay, very, very practical subject. So more practically you are trying to apply it. So let's suppose we wanted to measure, or we wanted to have the area of something. So how you can have the area of something? So we can have the area of that thing by measuring the length and the width of that rectangle. By measuring the length and the width of the rectangle. Okay, okay, okay. Now, when you are going to measure the length and the width, you are going to use some instrument, maybe a inch tape, maybe a meter scale, maybe something. Okay, something you will be using. Now, when you will be using that thing, you will be measuring something. So, no measurement can be 100% accurate no matter how we try. Okay. So, what is going to be the length? It will be having some error. So, let's suppose the length comes out to be 4 plus minus zero point 0.4 meter, and width comes out to be 2 plus minus zero point 0.2 meter. 2 plus minus 0.2 meter. Okay. Okay. Now you need to give the area. Now someone is asking you the area. What is the right way of giving the area? You must give the true value of area, and you must give the maximum error possible to the area. Okay, this is the right way of present any physical quantity. So what is going to be the area? The area is 100 mm square. This is not the right way actually. The right way could be 100 mm square plus minus what is the possible error in that, right? Okay, now we are going to see it. So what is the area? Sir, we know area is length into width. Okay, length into width, and we all know it. So what is going to be the error in the area measurement? So we can apply the principle that we just have learned. So delta A by A is equal to delta L by L plus delta B by B. So from here, delta A upon A. What is going to be the A? So you get the A right way. You just multiply the true value. Okay. You multiply the true value. So you are getting 4 into 2, that is 8. Okay, that is 8. Then we have delta L. What is delta L? So it is 0.4 upon L. L is the true value of it. Then delta B. What is the delta B? That is error in the measurement of the width. It is 0.2. And what is the true value of B? It is 2. What is the true value of it? It is 2. So what we are going to get? We are going to get 0.1 plus 0.1. So we are going to get here. So 0.1 plus 0.1, that is 0.2. So from here, what we are getting? From here, what we are getting? So when we are calculating this delta A here, so I'm writing it here. Okay. Please observe. Okay. Otherwise, you will think that the sir starts somewhere and then ends somewhere. So see, there is a limitation of the screen also. Okay. And when we are discussing something, I want to keep that whole discussion on one frame, on one slide, so that you will be more comfortable. Okay. Okay. So guys, what is going to happen here? So we are having delta A is equal to 0 0.1 plus 0 0.1, that is 0.2, and this is going to be 1.6. Okay, so delta A is 1.6 meter square. Delta A is 1.6 meter square. So what is going to be the A? A we must write, so 4 into 2, that is 8 plus minus 1.6 plus minus 1.6. I hope it is fine to everyone. Right? Right? Okay? 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 Wonderful. Wonderful. So we can write the area as 8 plus minus 1.6. Understood? Wonderful. Now let's do one more. Let's do one more. Let's suppose we have a cube, somewhat like this. Okay, we have somewhat cube like this, and the mass of the cube, let's suppose, is 6 plus minus 0.3 kg, and the volume of this cube is 2 plus minus zero point 0.2 meter cube, and you are supposed to get the density. Okay, you are supposed to calculate the density from here. So how you can do that? How you can calculate the density here? Can you give me something? Can you give me something? What is going to be the density? What is going to be the density? What is going to be the density here? So, sir, I hope you guys have attempted it. So, sir, it is very simple, no? Density, let's call it rho, is mass per unit volume. Okay. Now, this is in the form of division. So, whether it is division, whether it is multiplication, we can go like this. So, delta rho by rho is equal to delta m by m plus delta v by v. Very, very simple. Now, what is this delta rho? We want to calculate that. What is this rho? So you use the formula of rho on the true value. So mass per unit volume. So you are using the true value. So it is going to be 6 by 2. It is going to be 6 by 2. Okay, so this is going to be 3. So I'll write here 3 is equal to delta m by m. So this is zero point 0.3 upon 6. 0.3 upon 6 plus what is the error in the volume? It is 0.2 upon 2. 0.2 upon 2. So from here we can get this delta rho, and the delta rho here is coming out to be 0.45 kg per meter cube. 0.45 kg per meter cube. Okay, understood? Understood? Sir, here do we not require to reduce the round off it? No, you not, need not. Okay, because when errors in multiplication and division, so you are not actually multiplying them in the same way. Are you multiplying two significant quantities here? Two significant figures are you multiplying? No, sir, we are not multiplying. Are you multiplying any of it? Actually, no, you are not multiplying. So when you are not multiplying the significant figures, actually, you need not to do that. You need not to do that. Understood? Okay. Okay. So don't get confused in that. So I hope guys that in multiplication and division, how to deal with the errors, what is going to be the errors, that is now understood to you. Now, if the quantities are raised to some power, let's talk about it. So quantities, let's suppose we have some quantities raised to some power. We have quantities raised to some power. Okay. Okay, so let's suppose we have x is equal to a to the power p, b to the power q, c to the power r. And obviously a have some error, b also will have some error, and c will also have some error. Now sir, how we are going to deal with it? How we are going to get the delta x here? How we are going to get the delta x here? So what we can do here, sir, we can simply do one thing again by using the principle of differentiation. So, sir, do we need to do any differentiation? No, you need not. It is very simple. No, see delta x by x. Okay, now see a to the power p. So how we can write p upon delta a by a. So we can write it here p delta a by a, and then we can write, so see, here x is a to the power b, b to the power q, c to the power r. Okay, so now what we can write? We can write p to the power p delta a by a, then q delta b by b plus r delta c by c, right? Right. So if it would have written, see, if it would have written like this, a b upon c, you could have, let's suppose it is written as x is equal to a b upon c, then delta x upon x is equal to delta a upon a plus delta b upon b plus delta c upon c. Now what is the difference here? So instead you are having some power to a, you are having some power to b, you are having some power to c, you are having some power to c. Okay, you are having some power to c. Yeah, sorry again for the disturbance. So here delta x by x is equal to p delta a by a plus q delta b by b plus r delta c by c. Okay, so simply as I was saying, okay, so x is equal to ab upon c, x is equal to ab upon c. Okay, so now if it is ab upon c, it has no power, you can write like this. Now if it is a to the power p, b to the power q, c to the power r, then we have p delta a by a, q delta b by b, and r delta c by c. So this way you can get your delta x. So x you can find by the same thing. X you can find by the calculating from the true value, putting the power the same way, and then you can do like this. Okay, okay. So guys, we will be solving the questions of it. We'll be better understanding obviously it by the use of some questions. So, but that is what we are going to do in the next session. So guys, in this session, what we have done, we have learned about the error, and we have learned about the propagation of error, that is how the error propagate during addition, subtraction, multiplication and division. Okay, so guys, in this session that will be all. Thank you very much. Thank you for watching this session. Please do comment any question if you want to ask, anything you want to do. You may comment in the comment box. We'll be glad to answer you. And also, I would request you to subscribe your channel, NEET Success Simplified. We are here to help you. We are here to help in your preparation. Okay, okay. So guys, with this note, have a good day, and we'll see you in the next session.